Okay, guys, so this is the fifth problem of the exam that we have over here. So I'm gonna translate you so you can understand, okay? So first of all, it says we need to draw the function, right, that has the same requisites, okay? First of all, it says that f is continuous on this interval, okay? So we need to read really good here. Why? Because it says that is continuous from -5 to 2 and from 2 to 10, but it's not including the function. I mean, it's not including the value 2 here. What does it mean? It means that, let me delete this. Okay, what does it mean? It means that f of x has a vertical asymptote in x equals 2, right? Why? Because the function, right, is not, I mean, it's not do not exist for x equals 2, okay? So that's important to understand. Second of all, it says that the function evaluated in 3 and evaluated in 10 means that are 0. So these are the zeros of the function. Okay? Perfect. Now, now here you need to read also carefully. Let me do it with this one. Okay. Remember, every time that you have this expression, right, x plus 5 means that means that is the limit when x goes to -5. Remember that here we have to change the sign, so we write as this one, the limit when x goes to -5. And remember that I don't know if you remember the second topic, which was demonstration of limit. That what we did was to make a subtraction of what? Of the result of the limit. So now we know that the result of the limit is 3. So we write as this one, right? Limit when x goes to -5 of f of x equals 3. Remember, we also change sign here because it's going to the other side, right? Perfect. Now, focus on this. Whenever you have m, this means infinite. The sign of the infinite will depend of this one, right? And also, I have these definitions. These definitions, you can find them in the book called Differential Calculus by Villena. Okay, it's in Spanish, but at the end, you can understand the nomenclature. What it's saying here, that the limit from the right is going to have this expression over here. Okay, this means that we're going to have to do the limit when x goes to x sub 0, okay, from the right. Okay, so imagine this this graph. Okay, so I'm gonna do it this way. So imagine that you have this function, okay, and you want to know this point. I mean, you want to evaluate here in 2. So from the left, it's going to be that way, right? This is left. And right means you're approaching this way, okay? For a limit to exist, as I told you, the limit from the left and the limit from the right, sorry, needs to be equal. Therefore, the limit when x goes to 2 exists. Okay, perfect. So that's the sign of the value. So remember, when it goes from the right, you have to do x minus x0, the normal way, right? For example, here the normal way. Only that here we're just taking the function as itself, right? So this is gonna be this way, okay? I'm gonna write it over here. Please don't get lost. So okay, I'm gonna wait a second. I'm gonna make it here, okay? Perfect. Okay, and I'm here. I'm gonna do it this way. So this is gonna be the limit, right? When x goes to, I need to see the sign. Oh, in this case we have 2 minus x. Let's go to the left, to this definition here. So in this definition here, it says that when the limit goes from the left, we're gonna have the x sub 0 minus x, and if we notice, we're having the same here, as you can see here. So it's gonna be limit when x goes to 2, right? X goes to 2. Sorry guys, wait a second. Okay, when x goes to 2, right? From the left. Okay? From the left, always. Of f of x, it's gonna be, as I told you, this m means infinite. So, to the infinite. This one is gonna be the limit when x goes to 2. From where? From the right. So it's a plus of f of x is minus infinite. Now that we have this solution, right? I think I'm gonna delete this, okay? Just so you understand me, okay? Perfect. So let's draw this, okay? Together. Okay. So yeah, I'm gonna start plotting. You can draw the function. I mean, it's not a rule that you have to go from this and then this. I mean, you can do it whenever you want. Okay, it's not a problem. Sorry guys. Okay, perfect. Okay, let's go. So I'm gonna plot with this one, I think. Okay, good. So let's start writing first the zeros, okay? I'm gonna write, I don't know, over here, and 10 is gonna be over here, okay? I don't know. Okay, so we're gonna have here, this is 0, right? Function is 0 in this point. Okay, so we have the first task complete. Okay, cool. Now we need to know that here we're gonna have an asymptote, a vertical asymptote in 2 here, okay? Good. Okay, so now we need to understand something. It says here, right here, it's continuous here, but you start asking, okay, but I don't know, where do I have to plot this minus 5? I mean, I know a minus 5, it's gonna be, let me make it more. Minus 5, I know minus 5, sorry, it's gonna be here, right? But I don't know, right? I'm like, okay, so what can I do? But thanks to these requisites here, look here, it says the limit when x goes to minus 5 is equals 3. Perfect. So what can I do? minus 5, and I'm gonna say 1, 2, 3, let's say here, right? Wait, minus 5, okay, right? So the graph starts over here. I mean, it starts over here. Okay, good. Let's do something first. Let's do something. So, yeah. Now we need to go to this requisite. It says that when it goes 2 from the left, it goes from infinite, sorry. Means that you need to go, let me see. Yeah, this one, it's okay. Needs to be like over here. Like way up here. Right? And when it goes from right, it goes to minus infinite. Something like that, okay? So yeah, I can do something like this. At the end, it doesn't matter. So it goes like this. Wait, let me, I'm just put it here just so you can know, right? I don't know, it goes like here, up, okay? And then I know that it should be here, right? So at the end, here, look, it's gonna be like this, and needs to go this way. Okay, so now you can say, right? I mean, here we accomplish all the requisites as you can see. I mean, this one we're still working on, right? But this is accomplished. So you can say, okay, so maybe I can go that way, right? But not at all. Why not? Because then it's not a function. Remember something, that to be a function, the x, I mean the y values needs to have just only like one x, you know, because if, for example, if you go that way, then it's a problem. So no, you need to go this way. And I don't know, I mean, maybe you can do it like this. Let's make it more nicely, okay? So it's gonna be like here, and then it will fail. Okay, so that's how you can understand this topic. Okay, so yeah, I mean, at the end, what we have is this one. So I can do it like this, an arrow, so you can understand that this is how you need to draw the function. Okay, so thank you guys.